Alright, so question 6 says, an 8-gram bullet is suddenly shot into a 4-kilogram block at rest on a frictionless horizontal surface. The bullet remains lodged in the block. The block then moves against the spring and compresses it by 8.9 centimeters. The spring constant of the spring is 1,400 newtons per meter. What is the magnitude of the impulse of the block due to the spring during the entire time interval during which the block compresses the spring? Alright, so we're going to use the same formula again that we've been using. E mechanical of A equals mechanical of B. So K A plus velocity A equals K B plus velocity B. So 1/2 B squared plus 0, which is the initial velocity of 0 for the B. Constant is kx2. So our V squared is kx squared over m plus n, which equals V equals square root kx squared m plus m. Now, the impulse is going to equal this. Impulse is the same thing as this right here. So we're going to name impulse equals 10 to the negative 3 plus 4 square root 14 10 3 plus 4 times 8.9 times 10 to the negative 2 is equals 4,350 times 9 times 10 to the 2 equals 4 times 18 times 9 times 10 to the negative 2 equals 76 times 9 times erase this. It's 9 times 10 to the negative 2 equals 700 times 10 to the negative 2 equals 7 seconds. So this is the answer, which correlates to 8.